The age children learn to walk is normally distributed with a mean of 12 months and a standard deviation of 2.4 months. 33 randomly selected people were asked what age they learned to walk. Let's answer some questions about this situation. What is the distribution of X? X is the original population, and that would be the age at which a child learns to walk. So this is normally distributed with a mean of 12 months and a standard deviation of 2.4 months. The distribution of X bar, now that's the distribution of the sample means. And so we're going to use the central limit theorem to determine that. The central limit theorem says if the original population is normal, or n is greater than 30, in this case we have both of those things, then the mean is equal to the mean of the original population, so that would be 12. So this is 12. And the standard deviation of X bar is the standard deviation of the original population, which is 2.4, divided by the square root of the sample size, n. And n, in this case, is 33. So this is approximately equal to, rounded to 4 decimals, 0.4178. So that goes up here, 0.4178. So we've got two distributions going on. One is the original population, one is the distribution of the sample means. What is the probability that one randomly selected person learned to walk when the person was between 11.5 and 12.2 months old? So since this is about one particular individual, we want to use the original distribution n 12, 2.4. And so if this is 11.5 here, and this is 12.2 months here, the probability will be the area of this region I have sketched in. So we're going to use the online normal probability calculator from LibreText to solve this. We come over here to our calculator and we put in the mean, 12, and the standard deviation, 2.4. And we want to click on between, and we enter the two endpoints, 11.5 and 12.2, and hit calculate. And to 4 decimals, that probability is 0.1157. 0.1157. For the 33 people, find the probability that the average age they learn to walk is between 11.5 and 2.2 months old. So this is a question about the sample means. So what we computed above is the probability that X is between 11.5 and 12.2. Now we want the probability that X bar is between those same two numbers, because we're talking about an average. So that's easy enough to do on our calculator. Just come back over here, and the only thing we have to switch out is the standard deviation is now 0.4178. Everything else is the same. And we hit calculate, and to 4 decimals, that's 0.5682. So this is equal to 0.5682. Okay, for the next part is the assumption that the distribution is normal necessary. And the answer is no, it's not, because even though we were told our original population is normal, our sample size is 33, which is greater than 30. So no, not necessary. And finally, interquartile range. And this is the interquartile range for the sampling distribution of means, the average. So remember what quartiles are. The first quartile is that number such that 25% of the area is in this tail. So the area here is 0.25. And then the third quartile, I'll call this Z sub 1 and this Z sub 3. Third quartile is that number such that the area underneath the curve to the left of that value, I'll switch pen colors, is 0.75. So we come over here to our calculator, and let's clear out the probabilities up here and switch this to a 0.25 and make sure less than is checked and click calculate. And we get 11.7182 to 4 decimals. So 11.7182. And now I'll just switch that, take this probability out and switch this to a 7.5. And the third quartile is 12.2818. And finally, the interquartile range is Q3 minus Q1. So we subtract those two numbers and we get 0.5636. And that's it.